Okay, I'm Kolja. I'm working at the TIB Hannover in the Open Science Lab. I have a background in computer science, worked for 7 years had a startup company about hyperparameter optimization of neural networks and machine learning. And after that, I worked for 5 years specialized in the energy sector, so mostly machine learning for weather forecasts and energy transition forecasts. And till 3 years I'm now at the TIB Hannover and working on knowledge systems and in the culture field. So I'm creating tools for researchers that are working with semantic data and want to improve their projects with semantic capability. And 2 weeks ago we developed this new tool, Wikibase4Research. So my first question is, this is all about Wikibase and the Mediawiki framework. So how many of you do already have experience with Wikibase or Mediawiki? Not so, okay, some. So I will go a bit more into some details what all this is about. So, but first about motivation. In general, when we talk about research data management, we need specialized tools. Research data management is a really specialized field. And I found this picture of a cool specialized tool. I think it's a good picture because it stands for how specialized tools look to us. So I mean, there are a lot of functions here. No? I mean, the task it should solve, it's obvious, should open a bottle, but also as many specialized tools, it looks really complicated to us. And this is a big problem because nobody would use this tool, even if it's maybe, I mean, it's functional, it's very functional. And maybe if it has 100 functions to open several bottles automatically, but it's heavy, it's not usable, it's complex, nobody understands it. And that's not what we need for everyday tasks. So in the ideal world, technology is more like this. I mean, you have a lot of functionality that is so easy that even a child can apply it. But for sure, there are trade-offs. So whenever you make a tool easier, you have to hide functionality. So when you generate tools, normally you say, okay, we need function A and function B, and then it grows, and then it's a big monster. And then you need to cut this down, hide some functions, make good usability, and then it starts to making fun to use this tool. And that's what we want to achieve. Because especially in the research field, you often have interdisciplinary projects. So you not only have a computer scientist who say, okay, I want to train one AI, you maybe have someone who's specialized in traffic or woods or history, and they need to work with these tools to evolve their research projects. Okay, and here we came to the field of Mediawiki. The Mediawiki ecosystem is such a specialized tool. It's an open source tool. It's growing for decades and is used for a lot of specialized use cases. Mediawiki itself is the framework, the software framework, and it's used to run, for example, Wikipedia. So you all know it. So whenever you see the Wikipedia wiki and there are a lot of web pages that looks like Wikipedia, most probably they're using the Mediawiki framework. And then you have some extensions or you can specialize Mediawiki. For example, there is Wikibase. Wikibase is a bundle of extensions that you can install on the Mediawiki framework, and it acts as a knowledge base. So it's mainly a database, but the data is stored in triples or can be queried as triples. So like a subject, property, object. So you can build knowledge systems out of it. And it has you can query for that data. And Wikibase is used in many research projects because it is designed for collaborative data management. So it's really handy for research data management. And currently we want data to be fair. So we don't want data just to put it in the database. We want to find the data. It needs accessible. We want to share it. We want to connect these databases. And also we want to share our ontologies, our data models. Because in the old world, when you create your database, you just think of a new data model that fits your project, and then every property in this data model is defined in your specific spelling, so it's really hard to map databases to each other. And Wikibase is solving this problem, but Wikibase has no visualization. So there are some features like, okay, you can do queries and you can visualize this query, for example, as a map or as a timeline, but it's not really for user presentation. On the other hand, you have an extension Semantic Mediawiki, which is purely for, okay, I want to have a cool wiki, but I don't want to have static sites. I want to have semantic data, and this data has to be presented in my wiki. So I want to write an article, like in Wikipedia, and then I want to have an inline query which says, okay, please query from the database how many people are living in Berlin under the age of 20. And then you can display it in your article. And Semantic Mediawiki has a lot of capabilities for visualization. You can create timelines, maps, graphs, a lot of configuration functions. Okay, so the first thing is, if you want to set up such a thing, this is all you need. So in the old world, you need a server, you need to set up your operation system, you need a web server, a database. Then you go to the Mediawiki site, install the Mediawiki, you install all the extensions you need, and then you have additional services that you might need. For example, OpenRefine for an easy way to import data. So for example, I want to import Excel sheets or CSV files. This is OpenRefine. I need some runners that keep my database up to date. I need a query service that allows other researchers to access my data from outside. There's a specific query language, SPARQL, that can be used. And it also has a front end. So this is to access data from a Wikibase. And then maybe I need an Elasticsearch to make the search in my wiki faster. And this had to be set up manually, and you can assume this is 1 or 2 weeks of work and a lot of stress. Okay, then in the last years, this evolved. So there are already some Docker pipelines, official Docker pipelines. So if you already know, yes, I exactly know, I want to have Mediawiki with the default extensions. You can go to the Mediawiki page and there is a Docker container on it. You can run it and it's up. And the same is for Wikibase. So in the last weeks, they set up a new pipeline where you can say, okay, I just run my Wikibase container up, and then I already get the Wikidata query service, Elasticsearch, and the default extensions. But the main problem here is, what if you don't need the default? What if you have specific needs? Mediawiki extensions, there are 1,500 extensions that you can use. They are open source. Maybe you need some of these. Okay, no problem. You can just use their pipeline and maybe extend it and change their code. But then again, you need to learn how Docker works. So how many of you know Docker or Docker Compose? Yeah, a lot. Good, it's this community here. But a lot of the other researchers who focus on trees or history or traffic doesn't know that. Okay, and that's the motivation of our project. So what we created in the first is that we say, okay, we want to bundle all this and make it configurable so that you have a config file. So you don't need to change the code of the project or the Docker files. You just want configuration, like a simple package management where you activate or deactivate some functions, and where you can just switch from a pure Mediawiki to a Semantic Mediawiki, and next week you say, oh no, I need an additional Wikibase, and then you just restart your container again and set your project up. And then the next logical step was to say, okay, we don't want all this stuff in our project because this is just a tool. So here we have our config files that we have before, and now we say, okay, this is our project. we need the configuration of our tool. And we have some wiki pages that we created and images from our wiki and also data. And this we want to handle in a separate repository because this is our project and this is just our tool. And whenever our tool gets somehow updated, we just want to update it, but we don't want to include it in our repository. And one main benefit that we made in this tool is that we extended an existing tool. There was a prototype a few years ago, Semantic Wikibase, which was an attempt to combine Wikibase with Semantic Mediawiki. So to combine the collaborative database or knowledge base together with a semantic wiki that can visualize in a lot of ways. So you get the best of two worlds. And we further developed it, brought it to the newest to a newer Mediawiki version. So we now support the latest long-term support version of Mediawiki. And now I want to show you a bit how this works, how easy it is and how to set up a project with it. Okay, I will do this in the shell right now, but I wanted to have it in the as a presentation here. So it's just as easy. You need to, so the project name is Wikibase4Research. So we need to clone this project. And first we need to select, okay, what kind of wiki do we want to have? And then we just bring it up. So just for a quick start. Copy this here. I was told that I shouldn't shift this one here, but okay. I need to open a lot of terminals so I can access it here. Okay. So here's a Wikibase4Research repository. So we get the clone URL here. Don't know what's happening, but somehow Pardon?
Could you make the font size a little larger of the terminal?
Yeah, I try to.
Yeah, perfect.
Yeah. Currently, I'm struggling that I cannot paste, so maybe because of the screen setting. Okay, here it works. Here not. Strange. Okay, here we go. So we just say git clone and we clone this and maybe we clone it in a separate directory. okay, now we have Wikibase4Research, and you see here that we have here a folder wiki presets, and these are the presets like Mediawiki where we can select from. So the easiest thing we can do is just we start this up, and we have to give a preset folder. Maybe plain Mediawiki. Set it up, and now all the things from the big graphs are happening. So a Docker container is set up for the operation system. It downloads the Mediawiki code. There is a configuration file that I will show you here while this is loading. I like it when tools are not working in the presentation. That's great. So when I tested this, 2 o'clock last night, it was working. Here we go, just a bit lazy. Okay, so we have here the folder. We can make it bigger. Yeah. Here we have our Wikibase4Research project. And here we have the wiki presets. And within these presets, for example, I choose here Mediawiki plain. We have a config folder. And in this config folder, we have some general configs. So for example, default password for my wiki, and what's the address I want to publish my wiki on, and such things. I also have here a JSON file for the extension management. So in this file, we define, so this is really the config file of the wiki, which says, okay, which extensions do I want to have? So Mediawiki is installed all the time. We can have here semantic Mediawiki or a Wikibase. You can set versions for your configuration. So these presets works right from start, but you can configure it in your way. So now again. So now we test this here. So as you see, there's a logo already included, but it's just from another project. So when I refresh the browser, I just got a pure Mediawiki here. So fast, so simple. But what is a good thing to do is, we are again in our project. I will stop this one. And then we can use another one. So a good practice is not to directly use the wiki presets, but to copy the wiki presets to your own folder. So for example, we say, okay, now we have a make a folder for our own projects. And then we copy one of the presets, maybe a bigger one. For example, semantic Wikibase. And we want to have it in wiki projects, my project, and recursive. Okay, now we have a copy of that wiki preset, and now we can access this folder. And I mean, currently, the WFR Summer School is the Git repository of Wikibase4Research. So we don't want really to change this, because then we don't get updates. But now we are in a subfolder, and we can init our own Git repository here and publish this somewhere online. And then we have our configuration in our own repository, but we also get updates from Wikibase4Research whenever they occur. Okay, and let's bring this up. We need, as it is a new project here, we need to change some configuration here. So the main thing we need to set up is the init folder of our project. Because before we were here in Mediawiki plain. Now we have a separate folder here. And also we could define here, for example, some scripts that we want to run on update. For example, for data insertion, when you say, okay, I already have a data model, I need to run a Python script to insert it into Wikibase, we can just define that script here so it runs on startup. Okay, this runs now. While this is doing, there are also beside the config folder. So in the config folder, we have the local settings. The local settings are the Mediawiki configuration file. And normally it's a big bunch file with all the extensions being configured. So we strip this a bit up. So every extension has its own configuration file right now. And they are then managed. So whenever you deactivate an extension in your extension JSON, then it gets deactivated here also. So the system takes care of which extensions files needed, and now you can just configure your single extensions, and you can now share these configurations between your projects. So whenever you are doing multi-project management, like for example, we have a lot of research projects that already have a Wikibase, and now they want to have a front end, a visualization. And we use Semantic Wikibase to provide these front ends for the Wikibase users, and currently it takes let's say 5 days to bring up a front end from them, because they already have Mediawiki, and we use this tool for multi-project management, and we share code between these projects. So it's a lot of reusable code you can have them. You can just say, oh, I already used this extension in another project, and can just copy between projects. And also what we can do is, let me show this in another project here. This is a project that we did last week. It was for glossary creation. So for example, this is a semantic Wikibase. As you see, it doesn't have to look like Wikipedia. It can look somehow more like a web page. You can style it with CSS and whatever you want to do. And now we can, for example, have web forms to insert data in our database, because Wikibase is not so easy to manage, because as you have these triples, you need to insert it in a certain way. So the front end of Wikibase is nothing you can give to someone who just want to insert data, because they need to learn, okay, what is a statement, what is a qualifier, how does the Wikibase data model works. And by having this technology, we can now just create web forms to make it easier. For example, for public projects. Okay, now our semantic Wikibase is brought up here. And I already inserted some data here. So let me show you maybe. So yeah, this is the plain Mediawiki. So for example, we have here a section about Wikibase, and we can ask, okay, what are the entities that are defined here already? So I inserted these via an import script that runs in this container. And you see, this is the front end of Wikibase. So whenever you want to change something, you can just edit it. But if you want to add something, you need to say, okay, I want to have a new property. And then I have to look, okay, what properties are allowed in my data model. And yeah, so this is not the way a regular user would think of when inserting data. And what we have here on the main page is the simplest example you can think of, that we have an article here. And here we have had a dynamic query where we just say, okay, I want to query for the item with the ID 10. But I could also use queries like searching for properties. So for example, give me all cities that are lying in Germany with a certain amount of people. And then we can visualize this in another way. To show you a more complete project here, we will shut this down. And bring up another project. So while this is working, also when yeah. I was curious about the query language. The query language. Semantic Mediawiki has a specific query language. It's a Semantic Mediawiki query language. So yeah, one need to learn this. But it's not that complicated. And also, if you have people who say, yeah, but I already have all my SPARQL queries, do I need to rewrite them? No, you don't, because you could also say, if you have, you can embed your SPARQL queries into your wiki. So if, for example, you can use an iframe, a secure version of an iframe, to display all your SPARQL results that you already created in your wiki. We use this, for example, we have a semantic compact, which is a 3D viewer with annotated with semantic data. And we just display this within the wiki. So you have an interactive 3D viewer displayed in your wiki based on the data in your Wikibase. So you're really plugging some tools together. So I bring up a more complete version here. It's a project we are currently working on. It's about Herrenhäuser des Ostseeraums, Baltic manor, also manor houses in the Baltic Sea or around the Baltic Sea. There are, I think, about 8,000 houses registered in this project that have the specific entities. They have properties like geolocation, creation date, owners over the time, and also you have a lot of hierarchical information, like, okay, this manor house has a building, and in this building there's a specific room, and we have 3D recordings of this room, or there is a specific roof from a specific area. So there are a lot of details that architects and historians want to talk about. And it's not only structured data. Sometimes they also want to have unstructured information. So you want to have all the structured data that you gathered and you want to display it. Let me show you this. So as you see, what I really like is this hopping between projects. You just bring it up, bring it down. And every time I say set up or start, it's normally a 1 or 2 week of work. So this is really, for me, it's really exciting to do this. it's loading. Because here, as it's a big query, here you see it. Okay, so for example, what you have here is that we have some text that the researchers just want to write about the project and so it really looks like a normal web page. But this here is not an image or an iframe. It's based on Wikibase code. So you write a semantic media wiki query and say, okay, I want to have a map and it should be centered on the Baltic Sea and it should use Google Maps or Leaflet or whatever. We even could provide GeoJSON information to activate some shapes here and load it from our wiki. This here is currently a screenshot, but we could also include here our 3D viewer for some rooms. And then here you see we have a web page that just messed up, where we have our information. These are all items that are from our Wikibase. So we can click on it and say, okay, we have an item with its QID, and for sure you can make it look more nicer to have the name of the manor house here. You get all this information here, and you can write more queries in other forms. You can make timelines out of it to show a hierarchical view of the owners, everything you can imagine. And this is just a few lines of code to write. Also, you can then provide just some normal content pages. People have templating systems, so you can provide templates like every house should be structured in that way, and then the users can just use that templates and create their things. So, and a semantic media wiki is providing cool things. So, for example, you have a page here about a house. And then you say, okay, but I have some subpages for the architecture of that house or for the history of that house. And then you just use a small tag that MediaWiki should provide this information about subpages. So for example, that it should provide a linkable list of all the subpages. And when you click on it, it should provide automatically a backlink to the main page. So these are the small things in the MediaWiki framework that really makes these projects really fast and makes it a lot more fun to work with it. And as I said, it's about a week to set up a new frontend for a project. Okay, are there questions right now? Okay. So then I will show you here one of these queries, maybe how the semantic MediaWiki querying system works, and also some trade-offs you have. So trade-offs are Wikibase and semantic MediaWiki aren't supposed to work together. So they are just two cool tools that we plugged together. So we have two different data models that need to be mapped to each other. And not all the data types you have in Wikibase are provided currently. So we have provided coordinates, times, strings, numbers, like these things. But for example, Wikibase has some cool data types. For example, the extended datetime format, which is about time. And it is especially about uncertainty in time. So it's a datetime format where you don't have to specify, okay, you have a start date and an end date, because that doesn't provide the information. What does that mean? Does it mean, for example, for a building that it started exactly at this point and ended at another point? Or does it mean that it was somehow within this interval, or that you are unsure about it, or you can say, okay, if you don't have an end date, does it mean that you don't know the end date, or is it an open process that is still going on? So these are all things that are provided in the extended datetime format, and we cannot fully map that currently to semantic MediaWiki. So uncertainty is a bit of a thing you have to handle on your own. Also other things, there are some things like qualifiers in the data model that we can map, but that makes the queries a bit more complicated. So the more complicated your data model is in Wikibase, then you have some downsides in the in semantic MediaWiki that your queries are getting a bit longer. Let me show you here this one. I mean, I'm nearly in time, so I just used 2 minutes to show you this. So, for example, this is a project who created a glossary about climate change, and they want to save it in Wikibase, so can be reused, but they also wanted to present it here. So they want to, for example, search for vocabularies. And what we can do here now is that we say, okay, we have here several vocabularies that need to be managed here. And all of these need to be displayed, and you need a search form for it. So here we use templating system. To see where I can go to the text. This we don't need. So, a typical query of MediaWiki looks like this. You say, okay, I want to search for an entity that has the property P1. Okay, it's badly named here. So the property, for example, has parent with a value term. Or you could also say that has the property has parent defined. That has some sub-objects. Okay, maybe I skip the ifs here. And then you say, okay, just say what kind of data do I want to retrieve from that object? I want the status, I want the acronyms of these objects, the text, the vocabulary. And also you can then do a thing which is named property chaining, that you say, okay, in this object, I have a property that refers to another object, and this object has some other attributes, and you can just refer it to here by saying, okay, I want P3, point P4, point P5, so you can really link through the knowledge graph to get all the entities. And by using MediaWiki categories, we have also some basic kind of transitivity. Like, for example, okay, there is a child is a human, and a human is a living thing. So the knowledge should know that the child is a living thing, basic kind of transitivity. This is something you can achieve with this system. Okay, so Wikibase4Research is mainly about not a really new high-end technology. It's more about making things easier to work with existing technology. Bring your projects up fast, handle multiple projects, and combine semantic databases with frontends. Thank you very much.